Section 11.3 is on direct and inverse variation. Back in Chapter 4, we studied inverse variation. We studied direct variation. Direct variation is just like slope-intercept form, y equals mx plus b, where k is the slope. In direct variation problems, the graph will always go through the origin, and the slope of the graph is k. Y equals kx. And of course the b is 0. That's why the graph goes through the origin. In inverse variation, instead of y equals k times x as direct variation, we're going to have y equals k divided by x is inverse variation. Note that k can't be equal to 0. That would be a flat line. So k has to be some kind of a number. An inverse variation graph is going to look a little bit like this. It's going to start from infinity and it's going to come down and go out to infinity. So here's the kind of problem you'll be asked to do today. If x is 3 and y is 12, find an equation that relates them by varying them directly. So they're asking for us to find a direct variation equation. So we look at it with direct variation. That's y equals kx. So we start with our equation y equals kx, and then we're going to plug in 3 for x and 12 for y and solve for k. So we take 12 equals k divided by, or k times 3. We'll divide both sides by 3. K equals 4. Once we find the constant, we're going to plug it in to the equation in as the slope. So our final answer is y equals 4x. That's how they vary directly. In this section, they're also going to ask us, what if they vary inversely? What's the equation if they vary inversely? We follow the same process, we just use a different formula. Our formula is y equals k over x, so the 12 goes in for the y, the 3 goes in for the x, and again we solve for k. We multiply both sides by 3, 12 times 3 is 36, so k equals 36. We plug the 36 back into the equation for the k, and so they vary inversely as y equals 36 over x. So you'll be asked to do that on a number of problems in this section. What's the equation if they vary directly? What's the equation if they vary inversely?